So in this video I want to talk about ray tracing in gpvdm. gpvdm's had a ray tracer in it for a while, which means sort of the ability to project a light ray and see what happens to it in structures. But it's mainly been used within devices like OLEDs and things like that. But recently I've broken it more out of the model so it can be used independently and sort of have a play with light and do things like do sort of experiments like you did at school, where you had light boxes and lenses and prisms and things. So see, effectively have a bit of a sort of playground to figure out how optical systems will work. Were you interested in a particular system? So this demo is a Prism demo, which you get from new simulation and ray tracing, and there's Prism demo. So these are the optical sources, these arrows here, and you can edit these by clicking edit on them. Whoops. And this effectively gives you the X position, Y position, and it says sort of how many rays are going to come out of here. So for example, this has got Z is 20, so if we have this as 1, we just get 1 light ray coming out. If we have this as 20, we get 20 coming out. And if we also put, say, 10 in the Y direction, we get a block of light sources rather than just one. So let's put that back, and these are the objects we're going to scatter through. So there's no difference between these. These are just a straight up prism object. So you can, for example, make this solid by going View, Show Solid. They're exactly the same. So let's put that back so we can look through it. This here is a detector. This is an optical detector, and it will detect the rays that eventually hit this. And you'll be able to plot what rays have hit this, and this is configured in the optical detectors tab. So you can move all these components around. So you can move this around, and you can rotate it by pressing Shift. So I won't do that too much. So I want to show you this demo, and the same with the detector. The detector can be moved around at will, and the sources. So let's just line up the sources again a bit more. So let's just fire this off and make it run. So there we go, run. So we run it, and we're running it in a multiple wavelength mode, so we can see the quite beautiful rainbow that's come out of this out of the simulation. So if we look at this material here, this is edit. This material is BK7 glass. It's in glasses, so it's an actual glass where the refractive index changes to a function of wavelength. Oh, the light is gone. Okay. So that's all quite nice, and as I was showing you before, if you sort of wanted to change the number of sources, for example, if you wanted let's have 3 sources in the Y direction, and let's move this up a bit. You can do that. There you go. Sort of more complex ray tracing now. So let's have a look at what's going on with this detector. So if we go output and detector 0, you have multiple detectors, but this is just the first detector. You go detector 0, and you can effectively see where there's light. So this is wavelength 350 nanometers, and that sort of shift up there, we can see where the light is hitting that detector. So you can see there's a bit of difference in sort of where the light is detected from sort of 350. So if we look at it, well, I guess actually there's 3 rays hitting this now, so it's well, okay. Let's try and play with this properly and really demonstrate the detector. So if we set this back to one source, let's run this again, and let's shrink this detector. So let's try and edit that detector. See if it'll have this. Let's reduce the size of this. Oh, yeah, is that right? Size. There we go. And let's give it more points. Detectors. So it's got a grid there, I think, of what 8 by 8. So let's make that 20 by 20. So it's a really fine, high-resolution detector. Just run that again to figure out where the rays are going. So let's now, whoops, try and position this straight in the middle of the rays. There we go. Oh, that's not quite done it there, has it? So let's move that down a bit more. There we go. So that light should hit our detector. Rerun it. Let's look at the detector output again, and you can see we've got a straight cut through there of the beam at sort of that position detector. And as we change the wavelength, it should shift. There we go. It's starting to shift. There we go. It's shifting. So you can see effectively that the due to the diffraction in the due to this diffraction, what we're effectively looking at is this is the peak of the beam as we change the wavelength shifting over this detector. So there we go. That's the front shifting. That's quite nice. Okay, so that's that. You can also do things like, so I'll end this demo quite soon because I think it sort of shows enough of the capabilities, but you can do things like change these objects. You don't have to be prisms. If you go edit, and then you select the type, rather than prism, let's set it to, I don't know, say convex lens. There we go. That's weirdly rotated, but we can fix that by going edit, and let's set the angle, so rotate, let's make this 0 and 0. Okay, that's not right, so let's make it 90, say. What's that looking at? That's also wrong. Make that 90. Oh, it's looking better, there we go. So now we've got a bit of a lens. And it's a bit thick, the lens is a bit thick, so what we can do is we can shrink that. If you look at the little blue tab there, you can actually adjust the size of it. But it's a bit awkward, just adjusting, but yeah, it works. There's still quite a few things that aren't out of the interface. So run that. There you go. So we've got lensing, and so it's a pretty different simulation there. And obviously, you can put as many components in there as you want. You can copy that and paste it, and then do as you want. So I hope, I think people might find this useful. I suspect people might find uses for it that I don't know about yet. So if you do, drop me a mail, and if you want to use it for something that doesn't quite work for, let me know, and I'll see if I can I'll be up for any collaborations or anything like that. So thank you very much, and thank you for listening to this video.